everyone, welcome to Legacy IES. So we'll be continuing with our class 7th NCERT. This is chapter 4, the world of metals and non-metals. Now, first it talks about these two people, Yashwant and Anandi, who went to a village and all those things goes on. Now, it talks about very basic properties of metals and non-metals. Now, let's get started. So what this Sudarshan guy sees, he sees that somebody is heating an iron block, okay, such that it has become red hot. Once the iron has become red hot, then they have started hammering it. So he got confused why they are using it or hammering it like this. Then he was told that it is to make it into a shape of an axe. Axe, you might have known, okay, that is used to cut trees and all. Then so Anandi is getting surprised that wow, that iron can be beaten in flat shapes. So this is actually the first property it talks about. Okay, that is malleability. Okay, so what is malleability? Understand this very simple property of basically things that can be turned into thin sheets. That is called malleable. Okay, generally metals are malleable in nature. That is, you can beat them with a hammer or and they will turn into thin sheets. That's why you might have seen sheets of aluminium, correct, sheets of iron, all that same thing. Now it talks about, if you remember, we had learned about metals, some properties like they are lustrous in nature, they are hard, correct. Lustrous means they had some kind of shine, correct. They are hard means hard, you anyway understand. So materials like this, copper, aluminium, iron, all these are called metals, while the other ones like coal, sulfur, wood, these are non-lustrous in nature. Okay, then are all metals hard and solid? No, not really. There are certain metals which are soft in nature. For example, sodium and potassium. Sodium and potassium are actually soft in nature. Now, next thing, it talks about another metal called mercury. The property about mercury is actually liquid at room temperature. Usually metals are solid in nature. This is actually liquid at room temperature. Then it talks about the definition of malleability that I already told you. That is the property by which materials can be beaten into thin sheets is called malleability. Then example is silver foil, correct. Silver foil you have over different kinds of sweets, correct. Then you have aluminium foil that you use for wrapping to keep things hot, correct. Then it talks about that gold and silver are actually one of the most malleable metals, but still we tend to use aluminium. Why? Because aluminium is cheaper. Gold and silver have very good properties if you consider metallic properties, but the problem is they are very costly because they are not easily available. So that's why we use other things also. Then now another, the opposite of this malleable is called brittle. What is brittle? Brittle is anything that if you beat, let's say with a hammer, it will break down. That is brittle. For example, you must have seen like sulfur. Sulfur is like yellow color chalk, it will look like. Okay. Now, if you beat it, it will just break down into powder. That is called brittle. So, a piece of coal you must have seen. Coal can also be, if you hammer it, it will just break down. It will not turn into sheet or anything. So a piece of coal or lump of sulfur does not show this behavior. They break into pieces and are said to be brittle. On the other hand, wood neither gets flattened nor can be broken down into sheets. So wood, if you beat wood with a hammer, what will happen? It will not get broken immediately, correct? And it will not become a sheet also. So this is neither brittle nor malleable. Wood. Then it talks about holistic lens, the impact of iron on the progress of human civilization. So it talks about that earlier we used to have bronze age civilization, if you remember, correct. Now for making bronze you need copper, correct. Now so copper was actually discovered much earlier than iron. Then it asks you a question. Then later on came the Iron Age. If you have done the NCERTs of history, you must know this. Now, so iron came much later. Why did iron come later than the copper? So understand this. There are two reasons. First is copper is sometimes found as a metal directly, while if you talk about iron, so iron is mostly found as complex compounds. So you will have to extract iron out of these complex compounds. Correct? Now, other than that, copper is also softer and easier to reshape. You can easily reshape it, while iron you cannot really reshape easily. That's why human, when they started working with copper. Then over a time they developed ability to deal with different kinds of metals. The most important being became the iron. If you remember, then we actually moved from this region, the northwest part of India, to this part of India, that is the Indo-Gangetic plains, when we could discover iron. Because with iron, because it is so strong, we could cut down the dense forest that was here. Okay, all that you will study in history. Then another property is called ductility. What is ductility? So ductility is the property by which something can be drawn into wires. Okay, now, for example, you must have seen iron wires, you must have also seen copper wires. So this is ductility. That is, you can turn them into wires. Have you seen wires that are made up of sulfur, copper? No, correct? Not usually. So they are not ductile in nature, mainly possessed by metals. Then it talks about, again, gold is more ductile also. Gold is so ductile that 1 gram of it can be drawn into 2 kilometer long wire. 1 gram of gold. That long wire you can create using it. Correct. Now, the ductile nature enables you to make tea stainers. Correct. Those are also wires just put in a pattern. Correct. Now, then it talks about something that we know as steel. What is steel? So, steel is a mixture of metal iron and non-metal carbon. Wires can support heavy loads. Okay, so basically steel, which is a mixture of iron and carbon, it can support very heavy loads. It can withstand all of it. That's why it is used in suspension bridges, cranes, and all this. Now, one more thing good about steel is, or we know by the name of stainless steel, is that it does not get stained, that it does not get any kind of rust. Okay, we'll learn about this in, like, as we go in the chapter. Then we come to sonority. Okay, what is this? Or sonorosity also it is called. This is actually that it is again a property of metal, that metal when hit with any other thing, it tends to make sound. Especially when two metals meet, they create a sound. That is what you hear in bells. Correct? That is what you hear in some musical instrument, like you might have seen those two metal ones that they keep on clapping like this. Okay, so all those are properties of sonority. Then sonority, you can see this enables them to produce a ringing sound. For example, ghungroos. For example, the bell that you have had in your school, if your school was poor enough. Like I had this in my school. Now some schools have electric bells. Now electric bells are also not very different. Ultimately they also have a bell, but using electric motor, it is hitting it many times in a few seconds. So that is also same property, but it just does not look like this. Okay, then conduction of heat. Okay, so now let's understand these terms. So there is conductors, you have read, correct? Metals are generally good conductors of heat, all that. Now the property that it is talking about here is conduction. Now the transfer of heat, from one point to another of a material is called conduction. And materials that transfer heat are called conductors. Conductors and insulator, you do understand. Now, it is telling transfer of heat from one point to another is conduction. So, from one point to another. Now, this is the differentiating thing. Okay, so this is, for example, when you are, like, let's say you're cooking Maggie and now you are using a metal spoon, then you might have felt that after some time this whole metal spoon also becomes very hot and then you are not able to hold it. But if it is, let's say, a wooden spoon or that wooden spoon that you are using, then you won't be feeling heat. Why? Because wood is not a good conductor of heat. It does not do conduction very well. Understood? So conductors of heat you had seen of electricity, now you are seeing of heat also. Then conduction of electricity, this we have already seen. Good conductors which allow electric current to flow through them, bad conductors which do not allow electric current to flow through them. Now both have its use cases, correct? For example, in electricity chapter we talked about this, that around the wire you need insulating substances, then only you won't get the current. So it gives you an example of screwdriver. Again, two components, one will be metallic which will be able to conduct electricity, and that bulb will be brightened up, but the casing is always plastic or some substance so that you don't get the current. Then effect of air and water on metals. Okay, now let's see this. So it has, so what they have done, they have put iron nail inside this glass bottle with water filled in it. Now let's see. So it talks about something that we know as rusting. See, so moist air is responsible for the development of brown deposit on objects made of iron. This brown deposit is called rust, and the process of rust forming on object is called rusting. Understood? Simple. So basically, what is rusting? The process by which that brown deposit. What is that brown deposit? It is actually iron reacting with the atmospheric oxygen. That also we'll see. So this is rusting. Then there is something known as corrosion. So gradual deterioration of metal surfaces caused by air, water, any substance ultimately is called corrosion. Understood? So over time you must have seen metals, we also say this, corrode. Metals corrode over time. Now that may be because action of air, water, whatever, it is called corrosion. Then it talks about this. What is this? This is the very famous iron pillar of Delhi, which was made at the time of Chandragupta II. Now, what it has been more than 1600 years, it is about 6000 kg, and it has barely any rust. Okay, so it has not caught any rust. Why? Because they have done something to the iron pillar that we'll understand later. So basically, this is a very, so this actually, this pillar also came from somewhere in NP, and then it was transferred to Delhi, and over 1600 years also it has not caught any kind of rust. Okay, most probably it is some form of alloying that has been used, some metal must has been mixed so that it does not get rusted. So even those many years ago we knew something about metallurgy. Then effects of air and water on metals. So it talks about magnesium ribbon. Now this magnesium ribbon actually burns with a dazzling flame like this. Okay, white flames are produced, and what is left after burning is some white powder. Now if you test this white powder, what it is it acidic, is it basic, then you see what you get. So generally oxides of metals are basic in nature. Very important, please remember this, it is coming in a very small class 7th book, but it can solve many questions in UPSC. Okay, what is that? So general properties: metal oxides are basic in nature and non-metal oxides are acidic in nature. Always remember this. For example, what do you think about CO2? Will it be acidic or basic? It will be acidic. Why? Because it is a non-metal. It is carbon oxide, correct? So it is acidic in nature. That's why CO2 causes something that we know as ocean acidification. Remember this, correct? So this also helps you understand why CO2 causes ocean acidification, because it is a non-metal oxide, so it will be acidic in nature. Fine. Then it talks about a metal, that is sodium. Now sodium is so combustible that it reacts even vigorously with oxygen and water. So it is usually kept in kerosene. Does not react with kerosene. Now, what happens? So if storing sodium in kerosene prevents its exposure to moisture and air. Now, if sodium is given air and moisture, then can you feel that it can form something like NaOH? Huh? It can form something like NaOH, correct? What is this? This is a very strong base. So this is also basic in nature. Why? Because this is, first it can form Na2O and then it can even form NaOH. Basic in nature. Metal oxides also basic. Then substances that behave differently from metal in air and water. Now see what sulfur does. So this I have already told you. What? So what you do, you take small amount of sulfur, you burn it. Okay, now some gas will come out of it. You put a jar on it, you try to collect that gas, and then you put this gas in water to guess what kind of solution will be formed. Eventually what you know, if you're burning sulfur, so essentially what will happen? Some kind of sulfur dioxide, some sulfur dioxide will be formed, correct? Now sulfur dioxide will be what in nature? Acidic in nature. Simple as that. Then it is using the litmus paper to test this. So if it is acidic, acid turns what? Blue, litmus red. This is what is given. Then now if sulfur is directly placed in water, they don't really react. So substances like sulfur, phosphorus behave differently with air and water than metals. Phosphorus is stored in water as it catches fire when exposed to atmospheric air. So phosphorus is not safe in air. That is why it is always kept submerged in water. Okay, so different properties are shown by all these. Now, what are these? So these are non-metals which are not good conductors of electricity or heat, which are not sonorous, which are not ductile, which are not malleable. These are usually called non-metals. Then, now one thing should be clear with you, that all these gases that you see, oxygen, correct, hydrogen, nitrogen, all these, carbon, all these are actually non-metals. This you understand, but don't confuse it with other things. For example, glass, wood, rubber, paper, plastic, these are not non-metals, correct? Metal and non-metal is a classification for pure elements, not for some compound, some complex compound, some change. No, nothing like this. Metal and non-metal are how you define different elements. Okay, elements can be classified like this. Okay, so these are definitely not non-metals. Then metals and non-metals are subcategories of elements only. There are presently 118 elements that we know of. Okay, now it also says that most of them are naturally occurring while others are artificially made. So we have also artificially made certain elements. Okay, then are non-metals essential in daily life? Yes, of course. Why? What you breathe, oxygen. Carbon is in every part, whatever you eat, whatever you are completely, that is also carbon. Then nitrogen, correct? So nitrogen is used in fertilizers, chemical. Then you have chlorine. Chlorine is used in water purification. You must have heard that in swimming pool they put a lot of chlorine, correct? A solution of iodine is applied on wounds. It acts as an antiseptic. So there are of course many uses of non-metals also. Then here it talks about alloys. So alloys is what? Alloys is a mixture of two or more metals or a metal and a non-metal. For example, metal and a non-metal, if you mix, the example was steel only, correct? Iron and then some amount of carbon. Then metal and metal if you want. Then you have bronze, correct? So basically two, three metals, non-metal you mix together in, and then you get something that we know as alloys. Then these are not proper bonds. Understand this. This is just mixing in some proportion. Correct. So approximate ratios is also there, then also it's fine. This is not like compounds where it has to be exact. Okay. Like H2O is very exact in nature. Here, hydrogen and oxygen are in 2:1. Not so much for alloys. You can have more carbon also, less carbon also. You can have more tin also, less tin also. All that works. Then some special metals are also used in atomic energy, such as zirconium. Then in aerospace you use titanium. So all these are also used now. In India, many metals, especially iron and aluminum, are recycled to minimize waste and contribute to sustainability. Okay, so iron and aluminum are heavily recycled also. Okay, so this is done for your chapter 4. Now we come to chapter 5, which is changes around it, physical and chemical. Very simple chapter. You may know this already. Okay, now what is physical change? Such changes in which only physical properties like shape, size, state of substances change is called physical change. For example, melting of ice, correct? No new substance is formed, correct? Water, this is H2 only in liquid form or in gas form or in solid form. In solid form it is called ice, in liquid form it is called water, in gaseous form it is called water vapor. Is it change of the substance? No, this is just physical change, correct? Just the shape, size, state of substance has changed. This is physical change. Then we come to chemical change. So in chemical change, usually one or more new substances formed. One or more new substance is always formed. For example, the simple example is here you have here they have given exhale and breathe in, breathe out. So what you do, you take in oxygen and then you give out CO2. What is this? This is a chemical reaction. So usually chemical changes involve a process called chemical reaction, correct? So whatever reaction ever you have, ever you got fear of reactions in till class 10, whatever reactions you saw, all those were chemical change, because ultimately it leads to some new one or more products. Then see this one example, they keep talking about this. Okay, that is calcium hydroxide, CaOH whole twice, lime water plus CO2. This forms calcium carbonate. Calcium carbonate is CaCO3 plus H2O. Now, this is what we know as lime water, correct? Now, you mix carbon dioxide, you start getting insoluble substance in it. CaCO3 is like what you call it, Chuna. That is CaCO3. Now, the turning of lime water milky is also a test for carbon dioxide. So what you do, if you want to test that anything, let's say this beaker or some gas is being released here. Now, does this gas has CO2 or not? What you do, you put this gas in a container that has CaOH holders. What will happen? If it starts giving out some white precipitate, that means CaCO3 is forming. And how can it form? only when there is carbon dioxide present in this gas. Understood? So it is a test for finding out if carbon dioxide is present. Then you come to this very, you need not go in detail. So the vinegar and the baking soda that you find in home, that can mix and become carbon dioxide and other substance. Basically, again a new substance is formed. Correct? Then it talks about rusting again. So rusting, we have already seen what is rusting. Correct? So new brown colored substance is formed around this. This is because of forming of iron oxides. Then combustion. What is combustion? Now they are again calling the same chapter, which is magnesium ribbon. Correct? So you see this reaction. Magnesium in that ribbon is mixed with oxygen and air. Correct? While burning, it becomes magnesium oxide, which is like a white powder, heat and light. Simple. While burning, it will lead to heat and light. Then it talks about actually combustion. See, what is combustion? A chemical reaction in which a substance reacts with oxygen and produces heat or light is called combustion. So, in combustion, oxygen is inherent. This is how you define combustion. That is a chemical reaction in which substance is reacting with oxygen and producing heat or light. This is combustion. Then, what are combustible substances? Anything that can burn in the presence of oxygen is combustible. Correct? Now some may be very combustible, so that you will have to keep in some, for example phosphorus you will have to keep in water, or sodium. Those are very combustible, they will just react with the atmospheric air. But not everything like this. Correct? But most of the things are combustible in nature. That is, if you provide it enough oxygen and heat, then it will start combustion. So wood, paper, cotton, all these are combustible substances. Then science and society. Now, if a person catches fire, what is the best way to extinguish it? You just wrap a piece of cloth, or specially better will be blanket. Why this helps? Because if this is a person and you wrap blanket around him, suddenly the oxygen supply is stopped. Now oxygen is essential for any kind of combustion, so eventually what will happen? Burning will also stop. Correct? Same thing, you might have seen this experiment called where you're burning a candle and then you put a glass over it, then the flame extinguishes. Why? Because oxygen supply is cut. then then it talks about fireflies, or what you call jugnu in Hindi. So basically, what is a firefly? Firefly actually, they produce light by chemical change. So basically, inside their cells, they have certain cells which do certain reactions, okay, using ATP, or basically some form of energy that is there. Cells make energy, correct? So using that, it does a reaction from which light is released. Understood? That's why they glow in the night. Now you have started seeing very few of them because of the light pollution and everything. You're not seeing them anymore. Earlier they used to be very common around villages, even cities. Okay, so this is firefly. Then it talks about that every time you don't need a flame directly. Sometimes even heat can start burning things. So very famous example is this, using this magnifying glass. Now what it does, all these rays from the sun are concentrated at a particular point, and at this point enough heat is generated such that the paper starts burning. Because enough heat is generated, so paper will start burning from here. Correct? Ultimately you need to learn a concept called ignition temperature. Okay, see this. After some time, the paper becomes so hot that it starts burning. The minimum temperature at which a substance catches fire is the ignition temperature. Correct? For sodium phosphorus, the ignition temperature is so low that the normal room temperature is enough and they will catch fire. But for most things, it is not. For paper, just temperature would have risen to some more degrees Celsius and started burning. This is called ignition temperature. Correct? Now you read get to the conclusion, which is what you need for combustion. You can ask this to many students, they won't be able to tell this thing. Okay, even though this is 7th class. So the process of combustion requires three things. One, a combustible substance. This is called a fuel. Fuel can be anything that burns. Then oxygen, correct? Oxygen is always required. Then heat that allows the fuel to reach its ignition temperature. Like that, magnifying glass. Petrol also is not going combustion easily, but directly. But when you from that spark plug some amount of ignition is given and then it can start burning. So you need ignition temperature also. Then can physical and chemical change occur in the same process? Yes. For example, burning of a candle. Burning of a candle can do both. How? See, this is a candle. This is a candle. Now, this candle will have a wick like this. Now, if you're burning it, wick is also burning. Now, this wick, that is the thread that is in the middle. Now, the wick that is burning, do you think it will come back? Or is it becoming ash? It is becoming ash. It will never come back. Ash is a different substance. So, this is actually going through a chemical reaction. But some of the wax is getting evaporated completely. It is getting converted into CO2 and other gases. That is also gone. New product, that is also chemical reaction. But a lot of wax actually melts. So a lot of wax is actually melting like this. Now, can this wax be again used? Can this wax be again converted into different shape? Yes, it can be. So this part is actually physical reaction. Why? Because there is no change in substance. It was wax, it is still wax, just in more molten form. Understood? So it has chemical change also, it has physical change also. Then, are changes permanent? What do you think? Not necessarily. There are changes that can be reversed to the, for example, returning to the original object or substance which we have started, then it is called that it is a reversible change or it can be reversed. For example, you turn ice into water. Now, can it be again turned into ice? Yes. So this is reversible change. Then irreversible will be what? Which will not be back. For example, once you chop a vegetable, okay, or you make a popcorn, now from popcorn, can you make the corn again? No. Correct, because it has gone through, usually it has gone through chemical reaction, so can never be made the same back. Then it talks about, are all changes desirable? Now, for example, milk turning into curd or ripening of fruits, these are desirable changes. But there are undesirable changes also. For example, rusting of iron, decay of food, this is also chemical reaction only, but these are undesirable. So of course changes can be desirable and undesirable. Then, now sometimes some changes that we do have a very long term environmental impact. For example, the pollution or the release of the carbon emissions that we are doing, or that the developed countries were doing in the 1900s, 1800s, those are affecting us now. Correct. So some changes that occur because of human activity can have very long-term environmental impact. Then it talks about some slow natural changes. So it does not mean that every change you can see immediately. Like, have you ever seen a rock forming? Have you ever seen it getting formed? That this was soil and now you're seeing it and it becomes rock? No. Why? Because it is a very slow change. Very slowly it will become this. So now there is something known as weathering of rocks. What is weathering? So let's say this is a rock. Now, what happens? Because of heat, let's say it expands a bit. Then suddenly there is cold weather also, so it will contract. Now, because of this expansion and contraction, it will develop cracks like this. Correct? This is one way of weathering. The other way is, if there is water flowing like this, In the winters, what will happen? It will get frozen up. So it will become slightly wider. Again, weathering. Then water, air, all these also cause weathering in the rocks. So this is weathering of rocks. Temperature changes due to climate conditions, growing root of trees. That is also, you must have seen this. Then even freezing of water within cracks in rocks can break them. Then understand this, that it is not that it is always only physical. Actually, weathering of rocks has chemical change component also. For example, what happens? See this example. It's a good example. Yeah. So originally black colored rock is called basalt. So this is basalt rock. Now see, here it is still black, but when it reacts with water, it actually, because it is rich in iron, it becomes red. Okay, so see, has chemically changed to a red color layer. This red color is the result of iron oxide produced when the rock surface was exposed for a long time to water or air containing water vapor. These physical and chemical changes in rocks are collectively called weathering. Understood? So basically here, weathering is not just a physical phenomena, it also involves chemical changes. Like here you saw, this is a chemical change, correct? Some new substance is formed and because of presence of iron, it became reddish in color. Then it talks about erosion. Erosion is a very simple phenomena. Erosion means what? Erosion is, see this. This, have you noticed that fine sand collecting on riverbeds and lakes? Now, this sand is formed when rock pebbles, soil, sediments, all these are broken down. Now, these broken down sediments, when they're how they're taken from one place to another, that is done by erosion. Now, that taking away can be because of air that you see in deserts and all, correct? It may be because of water by the flow of river only, correct? So there are many ways in which erosion can be caused. So it says broken down and moved from one location to another by natural forces like wind, flowing water. This is called erosion. Understood? Then erosion during a landslide is an example of a physical change. Correct? Why? Because it is just breaking down the same substance. Nothing is changing chemically. Now, what will happen? The opposite also is true. When the speed of water actually decreases in an ocean, lake, and slowly things starts to settle at the bottom. Now, over a time, these sediments which are settled at the bottom, they tend to become like rocks. Now, please remember here also you can have certain chemical changes. For example, certain minerals that was brought as sediments will try to get deposited in different forms, in different compound forms inside these rocks. Okay, when we study about different types of rocks, you will understand this better. Okay, sedimentary rocks, all this. Okay, so what happens? So these sediments harden over time and become new rocks. Most of these changes take place over thousands of years and cannot be reversed. Why? Because it has both the physical and chemical component. Also, it is a very slow change that you cannot really observe, as in just by seeing. It is something that we see over many years going around. Understood? So this completes our chapter 5 also. That's it for this one. Thank you.